Hi guys, I hope this video finds you well. Hopefully you have had, I'm recording this before break, but you will be watching this after winter break. So I hope your break has been restful and everything you needed it to be. And you got a nice little quick breather from distance learning until we jumped into this week of distance learning. So today we're going to be learning about arithmetic sequences as linear functions. I love arithmetic sequences because they're one of those things you can directly apply to the real world. So say you are setting up an event at the Mini. An arithmetic sequence maybe is how many chairs to a table. If you have 6 chairs per table and you have a certain number of tables, what is the total number of chairs? That kind of thing is arithmetic sequences. And so I really like this lesson because it has a direct application into, things you'll do every day. So if you would pull out your notebook and label it lesson 3.5 with the title here, we're going to write down just a quick thing in your notes for your formula. This is going to be the one you use. You'll need it once we're back in person, hopefully, but later on we'll go back to this. I'm hoping. If we're in person, I would love to see you guys. I don't know what's going to end up happening. Maybe you'll know by the time you watch this video, but I'm hoping to see you guys in class. So the formula that you're going to have is A sub n. That's read as A sub n equals A sub 1 plus the parentheses n minus 1 times d. So it's important to notice here, d is your slope. This is going to be pretty similar to your y equals mx plus b. Your a sub 1 is basically your intercept, and you have your slope, and then you have your variable there, and you don't know what that is usually. So it's just kind of like y equals mx plus b, just tweaked just a little bit. So if you need to pause me and write this down in your notes. It's going to be super helpful. We're going to use it for each of our lessons or each of our problems here. So I'm actually going to copy it so we can use it for the next one. Pause me if you need to. I'm going to move on. So when it has something like determine whether each sequence is an arithmetic sequence, right? Yes or no. We don't need this equation yet. What we're going to do here is we're going to check out to see how much it's adding each time. So to go from 1 to 5, we increase by 4. To go from 5 to 9, we also increased by 4. 5 plus 4 is 9. To get from 9 to 13, that's plus 4. And to get from 13 to 17, that is also plus 4. So we would say, yes, this is an arithmetic sequence. And then we'll check out the next one. To get from 8 to 4, it's minus 4. 4 to 0 is minus 4. 0 to negative 4 is minus 4. Negative 4 to negative 8 is minus 4. So we would say yes. The other thing you could add in here, I'm going to maybe type it so I don't have to write it pretty badly. You could say increasing by 4 each time. Then for number 2, we are not increasing, but we are decreasing by 4 each time. I can't spell apparently. Decreasing by 4 each time. And that would be our answer for that one. Then we can check out 3. 3, we have 1 to 3 is 2, but then 3 to 9 would be plus 6. So when we're talking about arithmetic sequences, you're increasing by the same amount each time. So if you're thinking about that example with tables, you don't have some tables with 20 chairs and some tables with 6. That doesn't make sense. When you're talking about an arithmetic sequence, you're going to be thinking of it as adding the same each time. So in number 3, in problem 3, you're adding 2, then you're adding 6, and then you're adding even more. This is not an arithmetic sequence. You learn later about what this sequence is, but at this point, from what you know, you will say no. sad face. And that's how you do those problems. Pause this if you need to. Go ahead and try the other ones. So then the next thing we want to do is find the next three terms. That's the next kind of problem you'll have. Switch colors just for funsies. So the first thing we need to do is we need to figure out the slope, the rate. How much are we changing each time? So in this case, from 9 to 13, it's plus 4. 13 to 17 is plus 4, etc. Seems like it's adding 4 each time. So if we want to do the next three terms, we leave off at 25. I know my slope is 4, so the next one would be 25 plus 4, which is 29. Then 29 plus 4, which is 33. And then 33 plus 4, which is 37. And that's all you have to do. You just have to figure out what the pattern is and then keep following it. 4 to 0 to negative 4 to negative 8 to negative 12. I can tell you right now, from 4 to 0, it is not plus. I don't know what I'm writing, apparently. It is minus 4. We are subtracting 4 each time. There's a lot of 4s in these problems. This is minus 4. So we're just going to keep subtracting 4. So the last number we have is negative 12. Negative 12 minus 4 is not negative 16, it's negative 18. Then it's going to be negative 22. Then it'll be negative 26. Try the next one. Just check out what the slope is, how much it's changing the rate. The rate of change is what it's called up to a certain point, and then they also call it slope. It's the same thing. You'll predict what the next ones are for that one. So then this is the one that we're going to need that equation. I thought ahead already and copied and pasted the formula. I forgot I did that, but good job, me. So we're going to look for the nth term of each arithmetic sequence. So we want to know what our difference is, or our slope, how much we're changing each time. That's the first thing we need to figure out. I need to figure out what my d value is. To get from 1 to 3, 3 to 5, 5 to 7, it looks like we're adding 2 each time. So your d value is 2. That's your slope. So it says to write the equation for the nth term. So that means if we plug in any n, what is it going to be? So the first thing you need to do is identify what your d value is. That's your slope. I also want to know what my a sub 1 is. A sub 1 is talking about what is the first number in your given sequence. The first number that I see in my given sequence is 1. So my a sub 1 is going to equal 1. And then all you have to do from there is just write your equation out. So we have, I'm just copying it down as I go, a sub n equals, I'm just copying this guy right here. A sub n equals my a sub 1, which is 1. That's almost like your intercept, plus n minus 1 times your difference, which we found to be 2. Then it says to find the first 5 terms of the sequence. Oh, sorry, it says to graph the first 5 terms of the sequence. So what you're going to do, I'm not sure if they give you a graph in this or not. I would have to look. But basically what you're going to do is on your graph, your first number at 1, your first number is 1. So you're going to go 1 over, 1 up. And then it says every 1 that you progress, you're adding 2. So you're going to go 1 over and then add 1, 2, and that'll be your next point. 1 over, add 2. That'll be your next point. And then you can graph it. That's a terrible graph, but, does the trick. I'm going to try 9 with you and let you try 8. So again, in number 9, I want to figure out what my d value is and what my a sub 1 value is. A sub 1 is that first number, which is negative 4 in this case. And the d is how much you are increasing or decreasing. To get from 4 to negative 9, it's like we subtract 5, which makes sense. From 4 to 19, it's also minus 5. So that is your slope or your difference or your rate of change. Then just like we did before, you are going to use your formula to write an equation. A sub n equals 1 plus n plus 1. N minus 1, sorry, got distracted. N minus 1 times your d value, which is negative 5. I got distracted again and wrote the wrong thing. I apologize. It is now 6 p.m. at night as I record these, and I need to make sure I pay more attention. So our a sub 1 was not 1 in this case. It was negative 4. I'll make that look just a little bit better. And that is what you got. And that's how you do those problems. The last type of problem you'll get is a story problem, which I like story problems because it makes sense in everyday life. So Sarah is learning to knit. So she measured the length of the scarf. She's knitting to be 13 inches. Whenever I get a word problem, a lot of times I will just draw a picture. I have not looked at this problem yet, so I am brainstorming it with you guys. So it is 13 inches. Yesterday, she measured it, and it was 15.5 inches. That does not look like a 5. Today, it measured 18 inches. So in our arithmetic sequence, we have 13, 15.5, 18. So it says to write a function to represent the arithmetic sequence. So we're going to use that a sub n equals a sub 1 plus n minus 1 times d. Our d is our difference, or how much we're changing each time, or our slope, whatever you want to call it. And it looks like to get from 13 to 15.5, we added 2.5 each time. You're adding 2.5 inches per day. That's how much she's knitting. So then you want to figure out your a sub 1. What she started with was 13 inches. So we'll write that in. And then we can just plug this all into our formula. Let me switch colors here just so you can see. So we're going to copy it just like we see it above. A sub n equals 13 plus, so I just had to make sure I was doing this right, parentheses n minus 1 times 2.5. Just making sure I do this right. Now, if you wanted to see how many she knitted after 10 days, you could plug in 10 for n. N is the number of whatever it may be. And so that's how you do those problems. It's pretty straightforward. I love arithmetic sequences because they are straightforward. You get a formula. You can predict them pretty easily. Good luck with this lesson. Thank you guys for watching and taking the time to do that. I appreciate the people that I know when I take the time to do these videos, you actually take the time to watch them. So I'm really proud of you guys. Hang in there. Distance learning is tough, but you're going to stick with it, and I appreciate you guys. See ya.